Hello and welcome to a video on how to use a burette for a titration. This can be used for any titration, whether it's for an oxidation reduction reaction or for an acid-base reaction. A burette is simply a device, a long test tube with a valve on it that opens and closes. Make sure you note that if it is parallel to the spout, it is open. If it's perpendicular, it is closed, and it will have some varying degree of open as you adjust it. It has a measuring system on the sides. Make sure you look carefully as to how it's numbered. This is a 50 milliliter valve, I guess 50 milliliter burette, what you call it. But number starts at 0 up here and goes down to 50 over here. Some things you would need to use for this device or for titration: you need a clamp, a ring stand. I have some water here. You'd also want to have a beaker, usually a waste beaker or whatnot, to be able to drain into or to do your reaction in. So in this case, I would screw this on here. This is a clamp that is specific to a burette, but you could use any clamp that you'd want. You'd want to get get it positioned so you can use it. Here is just a general idea of how it sits up. You have your beaker below, and you have this thing here. Before I get too much into how the titration works, I would say that you need to do some preparatory work for the burette before we get started. Maybe one lab partner would get the stuff ready for the reaction mixture below, and one lab partner can get the burette going. The way you get the burette ready to use is, first of all, you must rinse it. Now, what I would do is I would rinse it first with water, and then I would rinse it with the chemical that you're going to be putting in there. So to do that is quite simple. All I would do is take some distilled water and I would run it down the end, and I would only put maybe in 5 to 10 milliliters, and then we use a rolling technique to roll this stuff out and into a sink. Now my sink is located right over here, and you can't see that, but you see I'm kind of using a rolling technique, and I would just simply roll it in this fashion, like this, and I'd roll it out as it drains out the end into the sink. The camera doesn't have a zoom on it, so I can't get a wider view or at this point. And then I would do this several times, also draining out the end as well, opening it and draining out the end here in this case. Okay. Now I do that several times, just filling it and then rolling it into the sink. Okay. Once I'm done with that, I would use the chemical that if I am putting an acid in here, rinse it with the acid as well and roll it into the sink. After we're done with that, we would simply fill the burette. Now in this case, I would fill it. I'm going to fill it with water. Okay. Sometimes it's difficult to see this thing, how you're filling it. So if you can, lower the burette to an eye level, which you see right here is at my eye level, somewhat perpendicular to my eye. And I'm just going to use water in this case. Okay. And I'm going to fill it with the chemical that I have in here already. Generally speaking, I almost always have the known chemical, and we'll talk about that in a moment here, that's in here, but not always the case, and I could give examples where that's not the case. Make sure the valve is closed, so I'm closing that with my hand, and I'm going to fill it. Now, I don't use a funnel. Funnels are available if you would like. Okay. Now, in this case, I didn't fill it all the way. It doesn't, you might need more, but at this point, getting it to 0 is not fundamentally required. Close is good enough. So I'm raising it back up here to a better level, where I can get my beaker underneath it, and I'll slide it over here. Okay. This part is still empty. So one of the main things you want to have as well is a waste beaker. Okay, usually sit around marked waste, and I would run some of this through until all of the liquid has been dispensed. If your valve doesn't open, or if your valve does not work, just let me know and I will help you out. Okay, and make sure there are no air bubbles in this end here. Okay, you want to have that full. Now at this point you're getting just about ready to start your titration. Your lab partner would have filled up all your other reactants in here, and you would simply place that below. Now depending on what you have below here, you may be stirring with your hand like this and adding. You may have a stir plate below here that's stirring for you. Regardless, mixing is something that needs to be done. Alright, so we have that. Right now, I want to measure how much I'm starting with. Since I didn't fill it to 0, I usually end up putting my hand below it. You can rotate this thing so you can see it. But either way, you should see that I'm going to sort of to measure this thing. I'm going to put my hand behind it, is generally how I do it, and I measure it. And I'm measuring to the bottom of the meniscus in this case. So I have almost 2.0 milliliters. So on my chart here, which is something that I use for all of my titrations, I have a known and I have an unknown. Okay, so on the side here I would put my big M for molarity, small m for moles, and L for volume, or V for volume. Now in this case, what I would do is I would write down my starting, well, this represents the entire titration, okay? But also for every trial I would have a start and a finish, and then a change. Okay. Now, if my known is my burette, okay, then this volume here, this change in start and finish, is this value right here. Okay. Now, depending on what you're looking for your lab, you could be looking for, let's say, an unknown molarity or unknown moles. Either way, our goal is to determine an unknown moles. Known, K stands for known, UK stands for unknown. My goal is to use the burette, which has a known molarity, and when dispensed from a start and a finish, this is it was 2.0 milliliters, and then when I end at my equivalence point, then I will have my volume. I will use the formula molarity equals moles per liter to get my moles. These will be equal based on the stoichiometric ratio of my particular chemical reaction. And now I have the moles of my unknown. Okay. From there, I could do several calculations with it. I could divide the moles of my original, of this substance, divide by my original volume to get molarity, or I can take these moles and just divide it by a mass to get a molar mass, or I take the grams divided by the moles to get the molar mass. Either way, the use of the burette, a couple things I would like you to make sure you are aware of is, one, how do you clean it? How do you set it up? How do you use this chart right here? Stupid light. Okay. We're trying to save energy here, so the lights randomly go off. That's fine. Let's keep moving. How do you clean this thing? Then we have this chart right here. This is standard for every single titration we do. Then every single titration is also going to get this start and finish. I could run 3 trials. I'll have 3 starts, 3 finishes. A lot of times my finish of one trial will be the start of my next. This is what you should be able to do.